Let's implement a stack and a queue using linked lists in C++. First, we're going to do a stack. So what is a stack? Let's draw it out first. So hopefully this is a good explanation of how a stack works. I'll do two explanations. So how a stack works, it's so stack follows last in first out while queue follows first in first out. Okay. So what last in first out means? Let's just draw it out. I think it's better if we draw it out rather than trying to explain it real quick. So let's draw that. So pretend you're let's draw a character. Draw a character draw a character right here. His name's let's call him Bill. Bill. And Bill works at Smith's. I'll do Smith S. And he's been tasked to pretty much he's been given a bunch of like juice bottles. And he has to put it into the freezer. Okay. So let's pretend this is a freezer. Okay. And it's like one of those freezers like you'll see. So he's given this, and this. A, B, C, D. So first he's gonna do A, right? So he puts okay, let's use the stack term so it will make more sense. So he pushes A. Okay, so he pushes A onto the freezer. We'll call this freezer stack. Okay. So he pushes A onto stack. Okay. And then he will push B onto stack. But this is like one of those freezers where it's like the moment you take one out, it will pull everything behind it towards you. That makes sense? So like for example, if he's gonna push B, then this one over here is now A, and this one over here is B. So like if you push the first one and you put the new one in front of the first one, okay? Now he's gonna do C, right? So this one's gonna be A, this one's gonna be B, you know? Actually, I'll just I'll just do this like that. So this one's A, this one's B, and this one's C. So this one's gone, this one's gone, this one's gone. And now D, right? We're gonna, yeah, okay, I should have done the other way. But now this one's A, this one's B, this one's C, and this one's D. Boom, he's done. He's done. Bill is done with work today, right? So let's erase Bill now. And let's erase his like little box, you know? So now here's customer A, you know? When he wants to take something from the freezer called stack, he has to pop it off stack. Okay. So pop it, here's the rule with stack. You can't do anything behind the one that's in front. Okay, so you can't be like, oh, let me grab this one like all the way in the back because that's like the one with the best expiration date. No, you can't do that. That's like the rule. So you have to take the most recent one. Okay. So here this character will take D, right? And then everything slides back down, you know what I mean? So let's see if I can erase this nicely. This goes away. This goes away. This goes away. This goes away. So now it's C B A. Okay. So this character is like, oh, he's happy now. Okay. So now he goes away with his milk carton and boom. Okay. And then okay, another good. He's like really mad, right? For some reason. Okay. He wants another one too. So he gets the one closest to him. Okay. So now uh he gets a C. So he gets his like juice, right? This one slides down. This one slides down. So now it's B and A, right? And he walks away happy. Okay. Say next day, right? Next day, oh, look who's back. He's winking at us too. Uh, was Bill was back? Okay, Bill was back. Okay, and he has to do the same job again, except this time, just to make the example better, maybe. He's given E and F. Okay, so he's gonna do E first. So he puts on stack. He pushes it onto stack. Remember, when you take something out of the stack, you pop it. When you want to push something, you push it. When you want to add something to the stack, you want to push it. Okay, so we're gonna delete these. So this one's gonna be A, this is gonna be B, and this is gonna be E. So this one's gone, right? This one's already on the stack. Now he wants to push F. Okay, so this one goes away, this one goes away, this one goes away. Well, not away, not never mind. This one goes here, A, B, E, and then F. Okay, And then, Bill's done with his work, so Bill's gonna go away with us, go away from us for now. And then, let's say this person is like, I want all of them now. So first he's gonna get the F. So now he gets F first. Okay, so stack goes down. Okay, so now it's A, B, E. Then he gets E, right? So let's say his hands are here. He gets E now, right? So stack goes down. He pops it off stack. My bad, I should have said that. He pops it off stack. So now this goes away. Now this is B, A. And let's say another character, he's like, oh, let me pop one off stack too. So he gets which one you think if he wants to pop one off. It's gonna be B. B is like the closest one. Okay. Then boom. This one's A now. My bad. I should have erased the B. But now let's say this one. It's like, oh, I want one too. I want one too. Right? He's gonna pop it off stack. Obviously, the last one's gonna be A. Now this dude and this dude is probably gonna be mad because it's been there for like a whole day now. It's not really fresh, right? So because it's been there for like how long? It was there for like two rotations of what do you call it? Like restocking. So that's how stack works. Okay. So let's erase this drawing now. So how it looks like is we're gonna do a linked list of a stack. So we're gonna have head. If you don't know how linked lists work, you should probably watch my other video if you want to watch that. Let's do let's not do Lincoln again. Do Bill again, right? And this time he's gonna have that S hat again, Bill. Right? And Bill wants to add. Let's do letters in this one. So let's do A, right? So A, since head is equal, okay, head's point to null. Let's do here null right here, null pointer. So heads point to null pointer at the start. So when we make this class, heads point to null pointer like immediately. So in the constructor, we're gonna make head point to null pointer. So since it's point to null pointer, we're gonna make head. So first, what we're gonna do is we're gonna first make one. So like a temp node, right? Actually, we'll have an if same as saying like if head equals null pointer, you can just make head equals new node, and this new node's gonna have a why did I erase that? Head's gonna point to this new node, and in this case, it's gonna be null pointer right here, and then it's gonna be A. Let me make a better handwriting. Okay, A, right? Okay, so now Bill put his new A. Now he wants to put a Z, say Z. So since head does not equal null pointer, we're gonna do it differently. So we're gonna make a temp, right? And this temp is gonna point to a node called that has Z in it. Okay. As of right now, this node points to null pointer as well. We'll just make a default by that. And then we're gonna make Z, this temp, the temp node that temp is pointing to, point to whatever head's pointing to. So instead of pointing to a null pointer, we're gonna make it point to whatever head's pointing to. And then lastly, we're gonna make head point to whatever temp's point to. So in this case, temp's point to here now. And then since it's a local variable temp, it's gonna be going away, but not the node, right? So now look, we kind of implemented a stack. Heads point to here, heads point to A. Now let's say Bill wants his Z back because he really liked that Z, so now he's like kind of like sad and stuff, right? So he wants his Z back. So first, before when we pop, we want to see his head actually point to something first. If head is pointing to something, first we're gonna do this. So we're gonna make temp point to whatever head's node is pointing to. So we're gonna make head point to not head temp point to here. Then next we're gonna say uh we're gonna keep whatever is in the node in temporary value. So I'll call it temp val or something like that and equals z, right? And then we're gonna say delete head. Lastly, we're gonna make head point to wherever temp is pointing to. So it's gonna point here now. Okay, that's how pop works. So that's what it looks like theoretically. Let's actually code it now. So this is what I wrote for now. This is all I wrote. Nothing much. Okay. This is from the last video. We'll just like leave that for now. So all we have in the private section is just a node called top. Uh, Yeah, when I say top, when I mean top is basically just head. So just don't get that confused. So in the public section, we're gonna have a link that's stack LL, right? And all it is gonna make top equal null pointer. And just to make our life easier, why not we just make a node constructor here too, like in data. And all it will just do is this data equals data, and then next, well, it already equals null pointer, I guess, so it's fine. So it just makes life easier, I feel like. So let's make our first one, which is avoid push. And for the pop, it's going to return the value. So in this case, it's going to return value pop, and then boom. And we're also going to make another one called like int top of stack. It so it doesn't pop, it just tells us what's at the top of the stack. And then that's it for now. So push, right? So we need to say, let's go back to our drawing. Let's make a new one. So again, so this is what top is right now, right? Point to null pointer right now. So if top equals null pointer, you can also say this if you want to be cool. But I feel like if this one seems more self-explanatory. So all we need to say is top equals new node, and we're gonna say, oh wait, we need to have a val, and then val. That's it. Okay. Else meaning that top is already pointing to something. So let's draw what we have right now. Oh, top points to a node, and this node points to null pointer, and it has a val right now. Let's say Billigan add two, so it's a two. So we see that top is pointing to something, so top does not equal null pointer, right? So we're gonna have a node called temp and equals a new node that has val, right? What do we need to do first? We need to make here. So we need to make temp here. Right now temp all is just node, and say Bill wanted to add a three, right? And by default this points to null pointer. We want to make temp's node point to wherever top is pointing to. So we're gonna make basically we want this right here. Okay. So think about the code real quick. I'm gonna just pause the video real quick. Try to think what should I say right here. Okay. Hopefully you thought about it. So temp next. So temp arrow next. So let's visualize it. Temp arrow next. So now we're referencing this one right here, right? Because temp arrow next. We're referencing this part of the node, which is whatever we are referencing next right now equals top. Okay. So right now we're making next point to wherever top is pointing to. So now lastly, all we need to do say top equals temp. Okay. Because now we're making top point to wherever top point to whatever temp is pointing to, which is a new node that we have, and that's it for push. That's legit it. That's it. Oh, where's the error? It's saying, oh, oh, that's from the earlier code. I'll just say node data equals zero or something like that. Should be fine. Yeah. So, uh, okay, now let's do pop. So first we need to say like, let's say user try to be funny and try to pop. There's nothing on the stack. Like it's like trying to say like you're at a vending machine and you try to like buy like a Coke, but there's no Cokes there. So it's like why? So if let's like have the only thing. So if top does not equal null pointer, this is our only if statement pretty much. Meaning that else it's gonna do nothing. So do we really need an else? Nah, not really. So so what do we gotta do? We gotta make a temp. So let's delete this temp, which is from like the push one. So we need to make a temp point to wherever top's node is pointing to. So temp, I'll call it T, points to here. So let's first do that. So node temp equals top arrow next. So let's see it. Top arrow next. What's top arrow next pointing to? Well, this next is pointing to here, so T is pointing to there now. Okay, good. So then all we need to do is keep that value somewhere. So we'll say will return -1 if no node is there. Meaning that I guess this in this case for a stack, it will never take negative values, hopefully. So in this case, we'll say return -1. But let's go back to where we were before. We need to we need to get this value right here. So as we said earlier, I think it's still in the drawing. Yeah, temp val. So int temp val equals top arrow data. Okay. Then lastly, all we need to say now is what? What do you think? Hopefully you said delete top, so this will go away. So delete top, and then we just need to top equals what? What do you think? Hopefully you said temp. So top equals temp, and then return temp val. And then boom, that's it. That's it for pop. So top of stack, all we're legit is gonna say is like this one's just saying like give me the top value without popping. So all we're gonna say is return top data. Check it out. Hopefully this will work. Let's see. So for let's first make one, I guess. Actually, we gotta make a what do you call it? We can just copy from here actually, because this will still work. We need to make a destructor. Okay, so memory leaks, you know. Stack ll. You just copy our code. If you don't know how to like deallocate a linked list, go check out my video towards the end. It's not that hard. You just need to. I think visualizing a linked list is really important instead of like trying to have to do it all in your head. Okay, let's do it. So stack ll. Anyways, so stack ll, we'll call it foo for now. So for int I equals 1, I is less than equal to 10, we'll just do those values. And then we'll do foo dot push just I. And hopefully when we do for int oh what was it? Okay. For int I equals 0, I is less than 10, I plus plus. When we do see out foo dot pop, we should be able to see uh what should it be? It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. When we run this to see g plus plus ll.cpp slash ALL. Yep, there you go. So let's check out Valgrind now. Good. So everything's good. Okay, let's do a queue now. So a queue, basically same idea, sort of. A queue is what exactly you think a queue will be. So like a queue in a line, like a queue at a line, basically a line. So like pretend you're at a line, right? Like I don't know, like a club, something like that, right? And this is Big Mad Bill. Okay, he works at a club now, and this is the door to get in the club. So let's say this person goes in first, right? Wait, that's not a good one. This person goes, this person goes, this person goes. So we're pushing people in, right? Let's say there's 1, 2, and let's say redo actually. Let's say we want to push another person in, it's gonna be 3, right? If we want to pop someone, we don't want to do 3. It's not a stack, right? Because that means this person's gonna cut the line, and 1 and 2 is gonna be mad, right? So we want to do 1. So when we pop someone, we're gonna do this one, okay? And when we pop someone again, we're gonna do this one. When we pop someone again, it's gonna be this one. Now let's look at it from a linked list standpoint, right? Because like, let's say this is a, we'll call it front this time. I think that's the move. I mean, why am I tripping about the name? But so front. So when we push, it's gonna look like this. It's gonna be one, right? And this one's gonna be null pointer for now. And then when we push again, it's gonna. And we could do it multiple ways, really. We can move it all the way at the end. Like we could do like this maybe, and this will point to here. Or we could do how we did it earlier, and then make it over here. So foo will point here, front will point here, and two like that. But let's do it the other way, because other way seems better. So then when we pop, all we need to do is land and move here. So yeah, we're gonna move. If we want to add an L, if we're gonna push, we're gonna push it to the end of the linked list. If we want to pop, we're just gonna do that and move it here. Okay. So pretty much let's copy and paste it. We'll call it QLL. Let's change that. Delete this stuff. We'll delete this stuff. Delete this. We'll call this front. Is why not? Front, 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 front. Okay, pushing. Okay, so we have two cases. If front front equals null pointer, all we're gonna say is front. Why does that look weird? Front equals new node with val, right? Else, what's happening? Else, we're gonna have to go through the list, pretty much go till it's the end. Okay, so I did this before in my linked list video. I had something called a goer equal front, and then uh prev equal null for now. And while goer does not equal null pointer, we're gonna make prev equal goer, and then goer equals goer next. We're basically trying to go all the way to the end right now. And once previous points to null pointer, I mean, once goer equals null pointer, the one previous will well, what do you call it? Will point to the last node. Okay, so all we're gonna say now is prev, not perv, prev next equals new node val. And that's it. That's it for push. If you want a visualizer, this is what it looks like. We're gonna pretend one is still here. We'll have goer and and uh, p, right? So p right now, we'll say it equals null pointer. Just know that, okay? So and goer equals where the front points to. So first we say this: prev equals goer. So prev points to wherever goer is going to, and then we're saying goer equals goer next. So it points here, and then does goer equal null pointer? No, it doesn't. So we're gonna make prev point to wherever goer is point to, and goer equals goer next. Look, goer equals null pointer now. So prev is pointing to the last node. Then we say prev arrow next equals new node. So in this case, let's say 3, and then null pointer right here. Okay, so that's the code for that. So int pop. Okay, all we're doing is just popping whatever is in front of front. Whatever is the node that front is pointing to, basically. So uh all we do is this. So first we say if front does not equal null pointer, right? Meaning that does it even point to something? If it does, if it doesn't, don't do anything. If it does, do this. So node temp equals front next, basically. Then we're gonna say oh, before we delete, we're gonna have an int temp val equals front data, and then we're gonna say delete front front equals temp, and then return temp val. And again, same thing, return -1. Nope, return -1. I can't spell. Delete. There you go. That's it. And instead of top of stack, we're gonna say uh in front. We're gonna say return front data. Okay, that's it. And hopefully, when we do this, it's gonna say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mm-hmm. And let's do Valgrind just in case. It's good. So that's how you implement a queue and stack in with using linked list. Uh, Instead of using linked lists, you could use the library in C++ called stack, and I believe there's a queue as well. Yeah, you could use these too. They do the exact same thing. Well, I feel like if you were to do like this, maybe you could practice linked lists and stuff. So if we were to do it also implements templates, which is nice. I think it's the same commands too. Oh yeah, instead like it's gonna do foo.top and then foo.pop. This one should do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, it's the same exact thing. Same exact thing. Push pop. You can search up the documentation on it for stack and queue. Actually, let's check it real quick. Uh, Stack C++. Yeah, last in first out. Queue is first in first out. So we have empty test weather. You can see size top. You can find the size as well, which we didn't implement. We could implement that, but it's already a 27-minute video. In place. Huh. I'm not. What does that do? Oh, adds a new element at the top. Okay, so basically same thing as push, I think. Swap. But yeah, that's it. So that's how you implement a stack in a queue in C++ using linked list. Hopefully you learned something. And yeah, good luck.